determine quantitative and qualitative effects of the disaster. There are two kinds of building a survey, rapid and detailed. The rapid is concentrated on making a brief evaluation of the building affected in the survey, and the detailed is the search for the buildings that were found unsafe in the rapid one. In order to know if that buildings must be demolished or repaired. Building a survey is a kind of collective consumption service that it means that this is a service that is collectively organized and managed, consumed via non-market, and at least partly paid for the public purse. Those estimation scenarios are scenarios in order to know which areas could be more affected, in order to know how many people should be trained in search and rescue, first aid, or also building a survey. The background of the research is split in three parts. In the first part, I'm going to show you how the scenarios that I use as an input in the research are usually formulated. That is basically a pre-earthquake loss estimation. The first step is collect semi-hazard data in the case study area. The second step is also to make an inventory of the element at risk and determine the degree of exposition to the hazard. This is the vulnerability curves applied. And the last step is make the estimation of the loss, of the possible loss. And sometimes it also include suggestion of the mitigation options. In the second part, I'm going to show you the methodologies developed in the world. I don't expect that you read the form. I just want to show you how they look like. Countries like USA, Mexico, and Japan have applied rapid and detailed survey. I have to tell you that a rapid survey should be done in 3 days, no more than 3 days, and a detailed should be done in 8 days. Other countries like Macedonia and Colombia have designed just one general evaluation, but in Colombia it has been reevaluated and they have been thinking doing also rapid and detailed. In the last part, I'm going to show you the other research studies related with the topic of resource allocation for emergency attention. Frey et al., for instance, they put forward a model, a mathematical model to estimate the efficiency and the performance and efficiency for tasks like search and rescue, like immediate restoration areas and immediate rehabilitation areas. Hugh, for instance, also he developed a model for simultaneous mobilization destination, traffic assignment, and departure schedule for multi-priority groups like elderly, children, and also disabled people. Here, formulate a method based in a 3D, map matching method, 3D, geocoded method, and indoor navigation mode. Shangao solved a problem with integer flow problem with side constraint. And Osdamar, for instance, he developed a model which integrates the multi-commodity network flow with the vehicle routing problem. Novaes et al. Use Voronoi diagrams associated with continuous association problems based on a spatial density of demands to solve location-restricted problems, specifically in transport and logistics that are fundamental in emergency attention. And Bellini et al. Put forward a statistical model to prove where the survivors need significantly guide the decision to deliver relief to them. And Bellini and Conley made an analysis of the cost and the value of the information collected when the environment changed in a foreseeable way, like is the environment after in the emergency time. Well, disaster present challenges and opportunities to the governments, and this research is concentrated in the rapid survey because it's oriented to save life, avoiding that people continue living in unsafe buildings. But to be effective and efficient, this activity requires to be modeled. And, but this service cannot be provided to everyone at once. For that reason, it's necessary to have an equity criteria to make the best use of the resources, that in this case are people. In the research problem, as Alvin says, little is known about the quality of the information collected in a rapid assessment, because there is an obvious conflict between speed and completeness, regularly compounded by a lack of access and security. Also, authors like Stratanova said that there are a lot of requirements in information, such as consistent information in search and analysis, in internet and distributed databases, also real-time update, positioning, routing outdoor working teams, and visualization in devices to support decision taking. The same author considered that in spite of the potential of the GIS for support the urban disaster management, the use of the information and the use of GIS is still limited in countries like in countries and in areas like Africa, Asia, and Latin America. And as we saw in most of the research studies related with the topic, they have been concentrated in search and rescue, evacuation lifeline schedule, plans to supply aid material, but any of them have addressed the issue of the building damage survey. And even the methodology developed in the world has been dealing with tools and techniques to collect information, how to assess the damage, how to carry out the inspection, the structure of the teams, the contents of the form and the announcement, but any of them has dealing with how to allocate the human and material resources according to different scenarios, parameters, and assumptions. So there is a gap in the knowledge about how to allocate the resources and how to manage the information collected. The main objective of this research was to design a procedure for the planning of a rapid building damage survey and manage the spatial information collected. The first objective is design a process model to estimate the number of trained people required. The second is develop a process model to optimize the allocation of the resources. And the third is design a conceptual model to manage the spatial information collected between the different levels of the organization. In the conceptual framework, well, there is an earthquake. An earthquake is a natural hazard in the domain of internal geodynamic processes. And this is a hazard that can be explained, can be understood, and the consequence of the event should be banned. But for that reason, we need planning and decision support system to support. And the framework of planning and decision support system has three phases: intelligent, design solution, and decision choice. And I divided the part of disaster management in a pre-disaster and post-disaster phase. The information management is all the information to be collected, and the technologies are all the devices to collect the information and manage the information. In the pre-disaster phase, we have risk identification and preparedness. Preparedness are all the activities in order to respond in a proper way to the emergency time. And finally, the model will be a combination between the assumption from the loss estimation scenarios, the parameters set out in the methodology, and the priorities predefined by policy. In the research methodology, there was a literature review, and I went through a case study of Bogota to be prepared for fieldwork. And fieldwork, the main activities were the survey, to know the location of the trained people, to know the condition of the training, and to know the availability or desirability to carry out, to participate in the inspection. The interviews were more about to study methodology, about how to train the people and the technology to use. And the secondary data that I collect was about the loss estimation scenarios and the location of the people already trained. The rest of the methodology follow the order of the sub-objectives that I'm going to explain you ahead in more detail. And this is the general overview of the research methodology. And well, the case study is Bogota, Colombia, is the capital of the country, is the most populated city, and also is the economical, cultural, and political center of the country. This city was selected because it's located in a country which is close to the meeting point of 4 tectonic plates, also is included in the Pacific Ring of Fire, and also the city is located in a medium hazard seismic zone. The city has been working since more than 8 years in the preparedness task, and also, well, this is my hometown for a reason I selected to work there. And this city has not experienced any big earthquakes in 1928. For that reason, a big one is long overdue. In that sense, the mayor, through the office in charge of emergency management, has done many investment in the preparedness task through the office that it's called by. That office is the office in charge of emergency management. And one of the tasks is the creation of the building inspection group. And since 2002 until 2003, since 2007 until now, they have been trained at least or more than 1,000 people. On fieldwork, I arrived to contact people in the office in charge of emergency management in the city, but also statistic data and cartography data in the country. I made requirements about information, facilities, as well as databases. I checked all the documents related with the topic. I designed a questionnaire to be applied to the study population that are people already trained in building a survey. And for the survey, I sent 824 emails and I made 986 phone calls. And I went through the databases, and also I searched for the last technologies used in Colombia and in the world to capture and transmit the occurred data. Well, I took the database, I removed the useless data, I organized the reminders, and eventually 121 people answered the survey in a positive way, but later was considered necessary to geocode also people who did not answer the survey in order to have a better visualization of the people trained in the city. Now it's possible, the margin of error in the location is around 30%, and now it's possible to see that people is spread out over the city, but there is a light concentration in the north and a lack of people in the southeast. Now I'm going to go to the analysis. The analysis will follow the same order of the sub-objectives for the reason I present again. And I start with the first sub-objective. The city has 3 loss estimation scenarios according to the same number of seismic return periods, 250, 500, and 1,000 years. These loss estimation scenarios are the framework to study the risk condition of the city. And from that loss estimation scenarios, I formulate a query to select just the residential areas, which are the areas which are the target areas in the survey. From that selection, I formulate another query to select just the inspection area. The inspection area are the areas with a degree of damage between 15 and 65% for the 3 return periods. It's possible to segregate the information at the parcel level, and this result takes me to come up with the space parameters, which are the result in the first stage of the model. The space parameters are the input to estimate the time parameters, and since this point I'm going to show you the worst scenario, that is the scenario in an earthquake with a return period of 1,000 years. And it's possible to estimate the time required according to the number of parcels and divided into the number of days. There are 3 in this case. And the time parameters combined with the organization of the inspection team. We have coordinators with C, supervisors, and teams that are consist of 2 people. You combine the time parameters with the operational times, that it's the time that the people used to inspect in one day, and also with the control range, that it's for the incident command system between 5 or 7 people per one, between 5 and 9 teams for every supervisor, and 5 and 9 supervisors for every coordinator. And we have a wide range of people required, that is between 1,000 and 18,000 people. In the second subjective, it's about people allocation. It's important to say that for the research, it's assumed that people will be at home for the time of the earthquake, or at least this is the first destination after the event, to check their family. For that reason, it's possible to estimate their availability, comparing their location with the areas with a high degree of damage, with a high number of injuries, and with a high number of casualties. Again, to know the availability, the worst scenario is chosen, that it's the scenario after an earthquake, the scenario of the number of casualties after an earthquake with a period of 1,000 years. After knowing how many people could be available, it's possible to start to allocate the service area. It means the area that they will going to inspect. In the research, I try with five methods, and the first one, it's the average number of parcels or blocks to inspect that come from subjective 1, but the result is not spatial. For that reason, it's more useful to support the other methods, or it's necessary to be supported for the other methods. The second is Euclidean allocation, which show a high coverage, almost 95% of the city. And based in the concept of distance travel by walking, that it's taking into account the average walking speed in the human, that it's 5 kilometers per hour. And the idea that the inspector don't spend too much time walking than inspecting. I use multiple wind buffer, but we have problems to know the boundaries for the third day, and network analysis, which has more accuracy and the boundaries are more clear, and route allocation, that is the most accurate method. But the problem is I have to do for each inspector, and in the research I found 723 inspectors, so I decided to take the farthest distance and combine with the buffer analysis to have a more realistic visualization of the coverage in the city, that now is possible to see that it's very low. But after looking at the coverage will be low, it's necessary to know which areas should be attended at first, which areas need more priority. I use community Bs to select the most priority areas, and the main criteria is population. For that reason, I use the spatial data set of population density, and then I start to play with different weights for the variables of density of built-up area, density of damage degree, or the secondary effects like landslide or fires, or the location of the inspectors. So now we have the second subjective. In the third and last subjective about information management, the model is designed in the concept of spatial data infrastructure, because it's important that all the entities involved in the emergency management can collect, store, update, and the most important, share information before and after any disaster. In this research, the spatial data set of people, people location, parks, and parcels, and roads are studied in order to define the meeting points. The meeting points are the points where the supervisor and inspector will meet each other. And in the research was considered to select the parks because they are not built-up areas that can collapse in an aftershock, and also they are easily recognized by the community. And to select the meeting points, it's possible to use two methods, central feature or mean center, with respect to the location of the teams or the location of the parts in some service area. And for the data capture, we can use mobile devices or paper forms, or use software application that can run on the smartphones like iPhones or Blackberries. And the data transmission will depend of the method to collect the data and the condition of fields. And finally, the information will start. Every supervisor goes to every home, collect the information. They give the information to the supervisor sends the information to the coordinator. The coordinator, the supervisor has to make a quality control of the information collected. Then the supervisor sends the information to the emergency operations center, and or the coordinator has to look for the way to the arrangement to digitize that information. But finally, information is sent to the emergency operations center, and finally, this information at the final of the day is possible to have the statistic of the habitability condition of the buildings in the city. This is useful to know how many shelters we will need, and how many people or how many houses should be repaired, or how many houses are totally destroyed. In the conclusions, for the first, again, I'm going to show the same order of the sub-objectives. In the first sub-objectives, it was possible to see that the space parameters and time parameters and the main input to estimate the number of trained people required. And also, we saw that the combination of the parameters, the control range, and the operational times in different scenarios give me different values and a wide range of people. But this range, it's useful to know how, in the preparedness phase, to know how many people should be trained in the short, in the medium, and in the long term, and in the real time to organize the resources that we have. And the inspection times per parcel should be calibrated through simulation exercises to calibrate the time, but also to test the performance of the people trained. So objective 2 is that food allocation is the most accurate method to estimate and allocate the service area. But it's necessary to look for a way to make in an automatic way, not for each inspector. And we saw that in the city, in the case study city, the coverage will be very low, that is between 7 and 10%, and the southeast of the city is the constant and covered area in all the scenarios. And the use of the spatial planning support system in emergency management is still restricted due to the time required for make the analysis, and also because of the limitation in the large-scale problems. We saw in the case study city that all the priority attention scenarios show that the southeast of Bogota requires priority always, but the problem is also that is the uncovered area. There is no trained people there, which is something to be solved by the administration. And the government should encourage the creation of a spatial data infrastructure to ensure mainly the sharing of information before and after any disaster. The best method to allocate a meeting point is select the nearest part to the main center of the inspector location. And the data should be captured using mobile devices, using just paper forms as a last and second alternative. The software application also not only allow the collection of geocoded data, but also it should have images to support the decision of the inspector about the safe condition of the building, like in application like CyberTrack. And the information management should be not only about the habitability of the buildings, but also about the emergency operation itself. The times, in order to calibrate the times to inspection the houses according to the size of the parcel or to the degree of damage. Thank you for listening to my presentation. Comments, questions, suggestions are very welcome. question.
How would you assume that your mobile devices would work after an earthquake and your cell towers would even be operable?
Yes, that it's a concern because well, a mobile devices is also that usually need a battery. A battery has to be with energy, and you cannot keep that element with battery all the time. For that reason, it's also necessary to consider use paper forms because in the first day maybe you will need to use paper forms, but in the second day you can use batteries. Or for that reason, it's also considered the use of software application because people trained can keep a software application in their smartphones. Yes.
Did you have to include the material of buildings for each area, and which could then be the part of the priority to go to? Does the southeast of Bogota have buildings that would be subject to collapse easier than other parts?
It's possible. Well, I didn't have that data. I mean, there is a vulnerability analysis, but we have to create. Yes, it's included in the degree of damage. Let me see. This information is an estimation that Andes University did for Bogota. And there is an estimation based on the vulnerability. Yeah, on the vulnerability, and that is one of the criteria or the variables take into account the degree of damage. For that reason, the southeast appears because it's the poorest area in the city, and the constructed methods and the constructed materials are not very good. But yes, there is a way, that is the degree of damage. The loss estimation scenarios are usually combined the condition of the hazard, that is the characteristic of the earthquake, and the condition of the buildings, and it's possible to know how the earthquake could affect a building, and that is the criteria of the degree of damage.
Good, thank you.
Okay.
One more question. You mentioned that the southeast of the city is the poorest. Would that lead to maybe emails not going through as well, people not having as many accesses to those things in your survey too? That was an area that was underrepresented, I remember.
Yes, it's a good question because for that reason I work in the methods to allocate the service areas because it's possible to see the lack of coverage and let me show you the other method. It's possible to see the lack of coverage in this area, but under this method, it's possible to see that there are areas that are, I can say, like overcovered. So you can displace or move these people to these areas. Yes, but it's better to know before in order that you can before the event you can think how would you move the people from that area to these areas, taking into account that many roads could be closed because of the debris, and also how many people could be displaced. And also you can, in advance, you can look for people. These people are usually engineers or architects. You can look for people who live there to invite them to be trained. Also, you can train the people around in order that they can distinguish which is a serious damage that is not easy, or at least locate the people in those areas in order that when an earthquake happens, they evacuate until someone can evaluate their buildings. Because the problem and the urgent issue in a building survey is that people don't die in an aftershock. If they don't die in the earthquake, don't die in an aftershock. Usually that happens. More people die in an aftershock than in the first earthquake.
There's no international standard for like a damage assessment? There's no international agreement about a standard assessment form for damage assessment?
There is an initiative in Bogota because, well, if the capital and the office has more money to make this kind of problem, but the standard was, if I'm not wrong, determined by by the USA, by the 18, this is the first one that I,
But there's no UN standard, there's no international standard for damage assessment data collection.
no, some countries have been, well, the countries who have been more affected by earthquakes, like USA, like Japan, they have determined some standards.
All right, very good. Thank you very much.